There's this incredible 50-year-old idea that's the secret sauce behind why your favorite apps can magically get faster overnight. It's a concept that powers, well, pretty much the entire modern digital world. And today, we're going to break it down. Let's dive in. So have you ever had this happen? You wake up one morning and an app you use every single day just works better? It's faster, it can handle way more data. But the cool part is you didn't have to learn a single new thing. So how does that even happen?
While it's not some kind of tech magic, the real answer is a brilliant principle that was dreamed up decades ago, way before the internet we know today. And what's crazy is, it's more important now than it has ever been.
To really get this, we've got to go back, way back to the source, to the mind that completely changed how we think about information forever. So, meet Edgar F. Back in the 1970s, he laid out a bunch of ideas that would become the absolute foundation for modern database systems. Think Oracle, and so many others. And right at the heart of all his work was this one single core principle. In that principle, it's called data independence. It's a really simple but honestly a profound idea. What you, the user, see and interact with should be totally separate from all the messy, complicated details of where and how that information is physically stored. The best way to think about it is like a wall, right? A wall separating two totally different worlds.
And really wrapping your head around these two separate worlds, well, that's the key to the whole thing.
Okay, so picture this. On one side of that wall, you've got the logical model. That's what you see. It's simple, it's clean, something that looks a lot like a simple spreadsheet. But on the other side is the physical storage, the whole messy, complicated backend of servers and wires where the data actually lives. Data independence is the big idea that lets us completely change one side without ever having to touch the other. Okay, let's make this real. Imagine our logical model is just this simple table of information. That table, it never, ever changes. But the physical storage? Way back when, you could have literally stored that info on a clay tablet. Then, technology marches on. We can take that exact same logical table and, without the user having any idea, we can just swap that out and move the physical storage to, say, a local hard drive. The user's view is completely identical. Now, let's fast forward to today. We can swap that single hard drive for a massive global data center with thousands and thousands of machines. And from the user's perspective, what do they see? You guessed it, the exact same simple table. And this is wild, but looking ahead, scientists are not figuring out how to store data in actual DNA. Even with a crazy leap like that, the principle still holds true. The user's logical view, that same simple table, stays exactly the same. And this is where the real genius is. The physical backend can be completely revolutionized, but the user experience doesn't have to change one bit. Users don't need to be retrained, they don't need new software, they don't have to adapt at all. That is the brilliance of this idea. Okay, so how do we actually build a system around this powerful idea? Let's take a look under the hood at the anatomy of a modern database. So a typical modern database has like 4 layers. The bottom 2 are the physical parts. You've got storage, which is just where the data is kept, and compute, which is all the processing power. And then the top 2 layers, that's the logical stuff. That's what you, the user, actually interact with. The model, which is how the data is structured, and the language, like SQL, which is how you ask the database questions. And most of the time, that logical model is just a simple table, kind of like this one, just a collection of rows and columns that's super easy for anyone to understand. Let's quickly break down what we're looking at here. Okay, so a row is basically one complete record. In this table of people, one row is one person. It's got all their info bundled together, their ID, their name, and their city. Simple enough, right? Now, here's a heads up. You're going to hear a ton of different names for this. Business folks might call it a business object. Other people might say record or entity. Don't let it confuse you. They all mean the exact same thing, just one of those horizontal lines in the table. Now, inside that table, there's almost always this really important column called a primary key. The best way to think of it is like a social security number for your data. Its value is totally unique for every single row, and it makes sure we can always pinpoint the exact record we need, no confusion. All right, so we've got the theory, we've got the structure, but what's the big payoff here? Like, why should you even care about any of this? This, right here, is the payoff. Because that logical layer is separate, engineers can literally rip out the entire physical backend. They can go from a small system on one PC to a massive one that processes petabytes of data, That's enough to store millions of movies in a global data center. And for you, the user, absolutely nothing changes on your end. You're still using the same tools to talk to the same simple tables.
You don't see any of that crazy complexity happening behind the curtain. All you feel is this huge, almost magical speed boost. And that brings us full circle, right back to where we started. The user barely notices any difference, except all of a sudden their apps feel like they're on rocket fuel. That is the power of data independence in action. So this 50-year-old idea has let our systems evolve in ways that honestly, its creator probably never even dreamed of, letting us swap out old tech for new. But it does leave us with this one kind of mind-bending question. What happens when the next huge leap in hardware isn't hardware at all? Something to think about.